In this lecture, we are going to study working of 3D printing process and various steps involved in 3D printing. Working of 3D printing starts with making a virtual design of the object you want to create. This virtual design is made in a computer-aided design file using a 3D modeling program. Computer-aided design is the use of computer system to assist in the creation, modification or optimization of a design. This scanner makes a 3D digital copy of an object and put it into a 3D modeling program. Digital file is created in 3D modeling program for printing. For this, the software divides the final model into many layers on horizontal axis. Now the file uploaded in the 3D printer. As a result, the printer starts working and creates the object by depositing layer on consecutive layers step by step. The 3D printer performs function of reading, slices and further on creates the proposed item by combining each layer together. The layer deposition is so smooth that you won't be able to see any layer marks, and result of which a three-dimensional article is prepared. Let us have a look at the steps involved in 3D printing. A 3D printer simplifies and accelerates the process of making prototypes and finished goods. Beginning with the computer-aided design, CAD data which defines a tool path, the 3D printer extrudes and deposits molten thermoplastic in layers to build the part from the bottom up. This makes very complex part easy to produce. You can see the enlisted steps related to 3D printing working. Let us discuss each step one by one. Computer-aided design is the use of computer system to assist in the creation, modification, analysis or optimization of 3D model design. CAD software is used to increase the productivity of 3D designer, improves the quality of design, improve communication through documentation and to create a database for manufacturing. Have a look at the process to create build file. In Catalyst or Insight, open your CAD file that is in STL format and select a material, color and slice thickness. Pick a build and support style to match your application requirement. Select an orientation or position in which the part will be built and then let the software do the rest. It sections the design into layers and creates tool path for both the part and its deposable support structure. Now click print to send the built file to the 3D printer. Next step is conversion to STL. In this, the CAD drawing is converted to the STL format. STL stands for Standard Tessellation Language. It is a file format developed for 3D system for use by its stereo lithography apparatus machines. In the next step, we will study the STL transfer to AM machine and STL file manipulation. A user copies the STL file to the computer that controls the 3D printer. There, the user can designate the size and orientation for printing. This is similar to the way you would set up a 2D printout to print two-side or in landscape versus portrait orientation. After this, machine setup function to be done. For this, insert the part of material and support material cartridge. The system will automatically feed the material filament to the extrusion head. Insert a base and close the chamber door. You are ready to build. Select your job from the queue and press the machine start button. The 3D printer heats the build chamber and brings the plastic liquefier up to operating temperature. Next step is build. Let the machine do its thing. The build process is mostly automatic. Each layer is usually about 0.1 millimeter thick. Through it can be much thinner or thicker. Depending on the object size, the machine and the material used, this process could take hours or even days to complete. Be sure to check on the machine periodically to make sure there are no errors. Build part as the Z stage platform raises to its starting position. The 3D printer starts with a few layers of deposable support material to provide a foundation. The same process used for the support structure is used for the part, except it employs a different material, a thermoplastic. Close-up of the process. In the FDM process, each layer of molten plastic is deposited on the top of the previous one. Now next step is removal. Remove the printed object from the machine and be sure to take any safety precaution to avoid injury, such as wearing gloves to protect yourself from hot surface or toxic chemicals. Post-processing. When the part is complete, open the chamber and remove it. Finish up by either washing or stripping away the support material that held the part in place. Many 3D printers will require some amount of post-processing for the printed object. This could include brushing off any remaining powder or bathing the printed object to remove water-soluble supports. The new printed may be weak during this step since some material require time to cure, so caution might be necessary to ensure that it doesn't break or fall apart. Now have a look at the process application, where it is to be make use of the newly printed object. Early in the design process, you can use FDM to make model to review form. Then update your design based on any flaws that you have identified. Again, print, review and update your design. Repeat the iteration process until you find the perfect concept. To prove your design, you can make a functional precision prototype. Use FDM parts for performance tests and rigorous engineering assessments. This is for today. See you in the next session.